For generations, Mars has stood as one of humanity's most compelling frontiers, a distant world painted in rust-red tones, cold, silent, and shaped by forces we are only beginning to understand. Yet today, for the first time in history, the idea of establishing a human presence on Mars has evolved from distant speculation into a legitimate scientific and engineering pursuit. As technology accelerates and international interest intensifies, Mars colonization has transformed into one of the most ambitious and consequential goals of our era. The motivation to colonize Mars is grounded in both necessity and vision. Earth, while still our home and cradle, remains vulnerable to natural disasters, climate instability, and potential global risks. Building a second home for humanity is not simply an exploration mission. It is an investment in the long-term survival and evolution of our species. And among all the planets in our solar system, Mars stands out as the most promising candidate for human settlement. Mars offers an environment that, while harsh, contains the essential ingredients for sustainable habitation. It has accessible water ice, valuable minerals, and a day length remarkably similar to that of Earth. Its gravity, though only 1/3 of Earth's, is strong enough to allow long-term human adaptation, and its atmosphere, thin and dominated by carbon dioxide, can be used to produce oxygen and even rocket fuel. These characteristics make Mars not just a scientific destination, but a potential home. But colonizing Mars requires us to overcome challenges unlike any humanity has previously faced. The journey from Earth to Mars spans months, exposing astronauts to intense cosmic radiation and physical stress. Upon arrival, settlers will confront temperatures that can plunge far below freezing, radiation levels higher than anywhere on Earth, and an atmosphere too thin to breathe. Every aspect of survival must be engineered. Oxygen must be produced, water extracted from ice deep below the surface, food grown in controlled environments, and habitats shielded from radiation and dust storms. Modern spacecraft and technologies are now being designed to meet these demands. Reusable rockets have drastically reduced the cost of space travel. Advanced life support systems can recycle air and water with remarkable efficiency. 3D printing technologies are being developed to construct durable habitats using Martian soil itself. Autonomous robots are expected to perform early construction tasks, building landing pads, storage units, and protective shelters long before humans take their first steps on the planet. Once a foothold on Mars is established, the development of a full-scale settlement becomes an exercise in engineering, collaboration, and adaptation. A future Martian colony would likely begin with interconnected habitats, pressurized modules equipped with laboratories, sleeping quarters, greenhouses, medical centers, and life support systems. Over time, these outposts may expand into larger settlements with power grids, water treatment facilities, transportation networks, and communication systems linking Mars to Earth. So the future of Mars colonization is ultimately a reflection of human ambition. It merges engineering with exploration, science with imagination, caution with courage. And as nations, private companies, and research institutions push the boundaries of what is possible, one truth becomes increasingly clear: the first generation to witness humans on Mars is already alive today. Mars is no longer just a distant world in our night sky. It is becoming part of humanity's future, an extension of our story, our curiosity, and our will to endure. And as we prepare to cross this new frontier, one thing is certain: the decisions made today will determine not only how we reach Mars, but how we thrive there. And if you want to know more about the future of flying cars, watch my next video.